just that we all sort of know where we were at, we had started with question 2. I know that the answers aren't here. It's because it's a new lesson. But we had done question 2 in the last lesson. And so what we're going to move on today is question 3, which is dealing with equations. Now, equations are another very, very important section in math. Equations are going to come, up in many, many different sections within math. So not only do they come up in equations, when you start doing number patterns, when you start doing graphs, when you start doing like trig sections, the concept of equations is a super, super important one. And so to get the basics of equations down is very important. Okay, so can someone tell me, when we are working with an equation, what are we actually trying to do? It does give you the instruction there, but what are we trying to do when we are solving an equation? You can put it in the chat or you can raise your hand. What is the goal of an equation, of solving an equation? Okay, so Tanjo's put on the chat there, to solve for x. So essentially what that means is we want to find
trying to solve for x.
Right, we're trying to solve for x. We are trying to look for a value that will make the whole equation true for x, okay? So, and Tanjo's put another little statement there. We want to know what value x needs to be in order to make the equation true, or to make the equation equal to each other. Now, to do that, we can use what we call inverse operations. Now, inverse operations basically means, that's not really a very good V, basically means that we use the opposite operation to what we originally had. My brain sometimes doesn't work at the same speed as my mouth. We are going to use the opposite operation to what was originally in the equation in order to solve our equation. So basically what that means is if we originally had a plus, we're now going to subtract. And the same would be if we originally had a subtraction, we're now going to do addition. The same applies for multiplication and division. So that is essentially inverse operations. We need to do the opposite of what we originally had. Now, this will always depend on what the equation is. So if we have a look at 3.1 here, we've got 7x minus 30 equals 4x minus 6. Now, there are lots of different ways that you can solve equations. There are also certain steps that I will show you here that that you won't necessarily show. It might be because you're more comfortable with equations, and so you can look at this and say, okay, cool, I automatically know what should be on the left and what should be on the right. That's fine. I'm going to do it very much step by step, lay everything out for you so that we're all on the same page. But if you can do this in a shorter or with less steps, that is absolutely fine. Okay, so the first thing that we want to do when we have a situation where we've got an x on the left and the right-hand side is we want to get all the x's to one side. Now, it doesn't really matter which side you put them on. So you can put them on the left or the right, it doesn't matter. I generally always put them on the left-hand side so that I always end up with x equals. That's just sort of what we're used to when we get an answer for x. So I'm going to get all of these x terms to the left-hand side. Now, in order to do that, this is where those inverse operations come in. So as it currently stands, the 7x is fine where it is. It's on the left-hand side. I'm happy with that. It's the 4x I have a bit of an issue with. So does someone want to tell me, you can either raise your hand or you can put in the chat, how can I move, for lack of a better word, the 4x to the left-hand side? What will I need to do to get 4x to the left? You can put it in the chat, so you can raise your hand. Or Atile, what am I going to have to do?
I think you're going to turn 4x into negative 4x.
Excellent. Well done. Okay, so guys, as Atile said to us here, this original operation of 4x was a plus. We don't write it in there because that's not necessary, but the original was plus, which means the inverse or the opposite operation is to subtract. And so in order to get it on the left-hand side, I'm going to subtract 4x. Now, essentially what I have done here is I have subtracted 4x on both sides of my equation. So I've subtracted a 4x on the right, which means those cancel because 4x minus 4x is 0. But I've moved it over the equal sign and changed the operation. So I've now got my x terms on the left, excuse me. I still got the negative 30 on the left, and I've got equals negative 6. So we're heading into a situation where we've got x terms on the left. The next thing I want to do is I want to get my constants, and remember we know that constants are terms without a variable, to the right-hand side of my equation. So what that means is I need to deal with this negative 30, and I want to bring it to the right-hand side. So again, who can tell me how I'm going to get negative 30 to the right? Sorry. Amathle, what am I going to do?
You can put negative 30 with the 6. So it becomes negative 6 plus 30.
Excellent. Well done. So guys, in order to move this negative 30, I'm going to do the inverse or the opposite. I'm going to plus 30, and that's going to move it to the right-hand side for me. So now on the left, I just have the x terms. And then on the right-hand side, I've got the constant. So the negative 6, but now it's plus 30 because it's the inverse operation. And now we've got all of our x's on one side, all of our constants on the other side. And so now the next thing that we need to do is we need to simplify. Now, when I say simplify, this goes back to what we spoke about in our lesson on Tuesday. Simplification means looking for like terms, seeing what I can add and subtract. And because we've done the first 2 steps, we've already got all of the like terms together. I've got all the x terms on the left, all of the constants on the right. And so I've already grouped my like terms for myself. And so all I need to do now is just add or subtract. So on the left-hand side, I've got 7x minus 4x. When I subtract 4x from 7x, I end up with 3x. And then on the right-hand side, I've got a negative 30. No, I don't. I've got a negative 6 plus 30. So now we just need to be a little bit careful. We need to remember that we're starting with a negative value and we're adding 30 to it. So can anyone tell me in the chat, what is negative 6 plus 30? What do I get when I add 30 to negative 6? Remember, I have no issues with you using a calculator if you want. Molemo, what? Oh, golly, Molemo left me. Emihle, what do we get? Emihle, you there? Okay, that's fine. I'm going to go to the next person. Your name here is, oh no, you've left me. Everyone's leaving me. Tando?
Hello, ma'am.
Hi.
So minus 6 plus 30 will give you 24.
And positive 24 or negative 24?
Positive.
Excellent, well done. So guys, I get a positive 24. Okay, I'm not drawing an entire number line for this because that will just take me way too long. But essentially, remember, you've got a number line whereby you've got your negative values, and that will eventually lead you into your positive values. So we get to 0, 1, and so we keep going. I now want to add 30 to negative 6. So I'm definitely going to head into a positive value. Okay, so remember, use your number line if you need to. I also have no problem with a calculator. Some teachers tell you to do it without a calculator, so that's where a number line is quite useful to us. But we get 24. Right, who wants to try and tell me what the next step is? Because remember, the whole point, and I think it was Tando who actually told us, of an equation is to solve for x. I need to get a value for x. So Oratile, what do I need to do?
Ma'am, we divide everything by 3.
Excellent.
3x and 24.
Excellent. So guys, what I'm seeing now is the fact that I have got this coefficient of 3. So we know that in between the 3 and the x, there's a multiplication. I need to do the opposite or the inverse of that. So I need to divide by 3. But if I'm going to divide one side of my equation by 3, I also need to divide the other side of my equation by 3. I can't do it just on one side. Otherwise, if I did it on one side, I'm not keeping the equation balanced. I'm just going to carry on here. So I'm going to have 3x divided by 3 is equal to 24 divided by 3. Now we know that when we've got 3 divided by 3, I just have 1. So you can write 1x, or you can just leave it as x. That's absolutely fine. And then we need to say 24 divided by 3. Now quickly in the chat, what is 24 divided by 3? Good, Amatle. 24 divided by 3 is 8. And so what we've done is we've solved for x. We now know that x must be equal to 8 in order for this equation to be true. Now guys, remember, if you are unsure of your solution to your equation, you can always check yourself. So there is a check for equations. You don't ever have to write this check in your answer, but you could do it on a calculator or on like a scrap piece of paper for yourself, just to make sure that your answer is correct. And your check is through substitution. So our original equation was 7x minus 30 is equal to 4x minus 6. If you now go and substitute the value for x that you found in place of x, you want to check that the left-hand side is equal to the right-hand side. So we would have 7 times 8 minus 30 is equal to 4 times 8 minus 6. I'm shocking with my 7 times tables. 7 times 8 is 56 minus 30. 4 times 8 is 32 minus 6. So now we just want to double check that the left is equal to right. 56 minus 30 is 26. And yeah, that's right. 32 minus 6, can I not do maths? Let's just double check that. Yeah. 32 minus 6 is 26 as well. And so what we see is that the left-hand side is equal to the right-hand side. And so this answer of x equals 8 is correct. So you can always do this check for yourself, and you don't have to do it like this. Just type it in on your calculator, type the left in, remember the answer, type the right and remember your answer, make sure that they're the same. But there is always a way to check your equation answers. Now, what this means is that when you are finished a test or a tutorial or an assessment or a worksheet or anything like that with equations, you should be checking your answers. So when you finish something like that early, go back and double check your answers for yourself. When you're sitting there with 5-10 minutes left, do a quick check for yourself so that you can make sure that you're getting those answers correct. Right, I'm just going to wait here for a second in case anyone wants to take a screenshot, and then we're going to have a look at 3.2. If you want to get started on 3.2, you're more than welcome to. How are we feeling? Like Melissa says, you can put a thumbs up or a thumbs down, or let us know in the chat. How are we doing? And it's okay if it's a thumbs down. Equations isn't everyone's favorite section, but it is a very important section. So that's why we're doing this, and we're doing it slowly. Okay, I'm hoping everyone's got their screenshots. Last 2 seconds. Right, 3.2. So again, we're carrying on with equations, which is why I said, if it's a thumbs down, you're not feeling great, don't worry, we're going to do some more right now. So 3.2, we've got 3 minus 2 times the bracket x plus 4 is equal to 5x plus 1. Now, when we have a situation like this where we've got brackets, Remember, this almost goes back to BODMAS. I don't really want those brackets there. So the first thing I'm going to deal with is I'm going to multiply out those brackets. Let me get rid of those brackets, and then I can go back to these 3 steps that I outlined here for myself, because then it's easy enough to follow. So when I multiply out that bracket, I end up with 3 minus 2x. Now we need to be careful. It's a negative 2 times a positive 4. We know a negative times a positive is a negative, and then 2 times 4 is 8, is equal to 5x plus 1. So whenever you've got brackets, you want to multiply them out or distribute the bracket so that they disappear and so that you can now go and do these 3 things. Get all the x's to the left, get the constants to the right, and then go and solve your equation. Right, so I'm going to give you guys, let's say 2 minutes to try this one by yourself. I will do this so that you can see the 3 steps. If you follow these 3 steps and remember your inverse operations, you should be able to solve this equation. Get all your x terms to the left, get your constants to the right, and then go and solve for x. If you only get a certain part of the way, that's absolutely fine. Just try your absolute best. And if anyone would like to raise their hand to explain how they got their answer, when you're ready, you're welcome to raise your hand and let us know. Remember those inverse operations. Very, very important that we use inverse operations. Otherwise, we're going to have a bit of a problem. And again, if anyone's feeling brave, you can raise your hand or you can put your answer in the chat. I don't mind if you're not feeling that brave. And if anyone's got some answers for X, we can start putting them in the chat so we can see. And guys, remember your answer doesn't always have to be a whole number. Sometimes we get fractions as answers, and that is okay. Okay, I'm going to give you another minute or so, and then I'm hoping I'm going to get some hands. Otherwise, I will go through it. No pressure. Okay, I'm seeing some answers come through. We're looking good so far. Okay, guys, I'm not seeing any hands, which is absolutely fine. We look like we're on the right track based on what is coming through on the chat. So let's have a look and see what this answer what this answer should be. so that we can carry on. Okay, so first things first, like I say, follow the steps that we've laid out. Let's get all of our x terms to the left-hand side. What that means is that the 5x that's currently sitting on the right needs to move. So this bud over here needs to move. We need to use our inverse operations. It is originally a plus 5x. So that means we have to subtract 5x on both sides of my equation in order to get it to the left. So what that means is now on, sorry, maybe did something weird there. On the left-hand side, I've got 3 minus 2x minus 5x minus 8 is equal to positive 1. Now, guys, just a quick side note here. You don't have to write the left in that order. If you put negative 2x minus 5x and then plus 3 minus 8, that's absolutely fine. The order isn't necessarily important. It is important that the signs are correct, but you can write it in any order that you want. Right. X terms on the left. Now I need to get my constants to the right. That means this negative 8 and positive 3 need to come over. Positive 3, the inverse is to subtract 3 on both sides. And then the negative 8, the inverse is to add 8 on both sides. And so what we end up with is a situation where on the left, we've got the negative 2x minus 5x. And on the right-hand side, we've got 1 minus 3 plus 8. Now, again, if you had written 1 plus 8 minus 3, that's cool. Order is not important. The sign is important. So as long as it's a minus 3 and a plus 8, doesn't matter what, or English. Thank heavens we're not in an English class right now. Doesn't matter what order we put the terms in. Oy. Okay, now we go and simplify. We're getting there. On the left, we've got a negative 2x minus 5x. So again, if you're struggling with this concept a little bit, imagine your number line. This is my very beautiful number line.
Very beautiful.
Yeah, I'm a real artist. Clearly English and art are my strong subjects.
Yes, because
Okay, so we're at negative 2 and we want to subtract 5. 1, 2, 3, 4, 5. That means that negative 2x minus another 5x is negative 7x. Again, obviously, if you're using a calculator, cool. But if not, number line. Then we've got our 1 minus 3 plus 8. So if I just extend this number line a little bit, nearly forgot my numbers there for a second. We're starting at 1. We are subtracting 3, 1, 2, 3. So I'm now at negative 2. And then I want to add 8. So 1, 2, 3, 4, 5, 6, 7, 8. I end up at positive 6. So I've got negative 7x is equal to a positive 6. Now we saw that when we've got that coefficient or the number in front of x, we're not a huge fan of that. So we want to get rid of it. We want to divide both sides by negative 7. And it's very important that we divide by the negative as well, because what we want is just the x. It mustn't be a negative x. It must just be x or positive x. So I'll have negative 7x divided by a negative 7 is equal to 6 divided by negative 7. We know that the negative 7s essentially cancel out. And so what we're left with is x is equal to negative 6 over 7. Now, importantly, when we write negative fractions, the negative sign we generally either write with the numerator or we write it in front of the fraction and then the fraction. We don't generally write the negative in the denominator. It means the same thing, but just as like what we usually see, so that you get used to what we usually work with, the negative either goes with the numerator or in front of the fraction. It doesn't really go at the denominator. Right, so I'm going to give you guys a second to take a screenshot of that. While you're doing that, can you just give me a thumbs up or thumbs down in the chat how we're feeling after 2 equations questions? we are going to take a little break just because we are already halfway through, and it's good to give our brains a break before we carry on. We will carry on with equations, so don't stress if you're a thumbs down.
Mm.
And guys, when I ask for a thumbs up or thumbs down, it is quite helpful if you do let us know, just so that we do get a general idea of how everyone's doing. And it's okay if it's a thumbs down. It really, really is. You're not the only person if you're a thumbs down. You're also not the only person with a thumbs up. And if we are a thumbs down, if you have a question, please do ask, and you can either send myself a message and Elisa a message, or you can raise your hand. If it's a case of you just need more practice, that's absolutely fine. We're going to do more. Okay. But if you have a question, please do ask us.
And I'll also send them a DM, all of those who said a thumbs down. And please watch out for those messages and then get back to me, please.
See, guys, this is why Annalise was the best.
Yeah, I'm here for you.
Yeah, exactly. It's like your personal cheerleader.
Exactly.
Okay, I'm hoping we all took screenshots. If you are busy with Nelisa, you don't have to listen to me right now. This is our little break for the day. So I mix it up every now and then. Those of you that were with me last year will remember these fun math puzzle things. I have changed it up a little bit this year. So be prepared. But to start off with nice and easy, this is what we call a brain break. Now, brain break is basically we take 5 minutes from the lesson and we just do something a little bit different, just to give our brains something else to do that isn't necessarily focused on the work that we're doing. I generally always try to put a little joke up. I try and make it maths related, but honestly, it's very hard not to repeat maths jokes. So sometimes it won't be a maths joke, it's just a funny little joke. But today's brain break, we have got this, there's a specific name for it, can't remember now, but like this emoji puzzle. And we want to figure out what each of these things, or the value of each of these things. Now, this is basically an equation, which is what we're currently doing. So yes, it's a fun little puzzle, but mathematically, these are also very helpful to us. So for those of you who've never seen this before, that's absolutely fine. Just so that you know what it is that we're doing. Essentially, what we want to do is we want to work out what the boots, the sunglasses, and the coats are as a value, so that we can go and work out the final value, or the final expression's value rather. So we can try this one together because it is our first brain break that we're doing as a class. And it's absolutely fine. So let's see if we can try and do this together. Now, if we start with the first one, the first one's probably the easiest one to start with because I'm adding 3 identical values. It's 2 pairs of boots plus 2 pairs of boots plus 2 pairs of boots. So you can almost imagine this like an equation of, if I'm adding 3 identical things, it would be x plus x plus x should be equal to 42. Now we know all those x's are like terms. So what I actually have here is 3x is equal to 42. And we know how to solve this. If we divide 42 by 3, we're going to get what x is equal to. So exactly as Tawana has just put on the chat, if we divide 42 by 3, or if we go and work out what the pair of boots is worth, each of them is worth 14, because 14 plus 14 plus 14 gives us 42. Now that means that every pair of boots is 42. So this pair of boots that I see here is 42. No, sorry, I'm just talking absolute nonsense. Let me start that sentence again. Every pair of boots that we see is worth 14. So this, in the next step, the pair of boots is 14. But in the last step, I only have 1 boot. So on the chat quickly, what is one boot worth if 2 boots is 14? Nice, Matle. 1 boot is only 7. Okay, so 2 boots together is 14, 1 boot, 7. Nice, guys, you're on it. So let's have a look at the second equation. The second equation is 2 pairs of glasses plus 2 pairs of glasses times 14 must give me 150. Now, what I want you to be careful of here is the fact that there's a times and there's a plus. So we need to remember BODMAS here. We need to remember our order of work, which means that the multiplication must happen first. Now, again, you can sort of try and imagine this as an equation for yourself if you wanted to. I'm not going to use X again just because we used X already. But if we made these sunglasses Y, we would have Y plus Y times 14 is equal to 150. Now, again, 14 times Y or Y times 14 is actually just 14Y. And so I've got like terms here. So if we go and add the Y's together, and I'm just going to go up here, we would have 15Y equals 150. And so we can solve our equation, which means that a pair of sunglasses, or 2 pairs of sunglasses rather, is equal to 10. And so that then tells me that this pair of sunglasses is 10. Now this makes sense. If we start with BODMAS, 10 times 14 is 140. 140 plus 10 does give me 150. So these are basically equations. We're just using pictures instead of letters or variables, but it is essentially an equation that we're trying to solve here. So now in the third one, we know that the pair of glasses, now it's only 1 pair of glasses, is worth 5, very similar to the boot. It's half of what the double pair of glasses was worth. And again, we've got plus a coat and times a coat, and we need to get 54. So I'm going to give you guys a second to try and figure this one out. It's very similar to the one we did last. What is the coat worth in order for me to get a coat times 5 plus a coat to get 54? Malemo, very close with 10. Remember, guys, we need to remember BODMAS. So the times has to happen first before the addition. Right, for those of you saying 10, just have a look at this. If it was 10 times 5 plus 10, we do the times first, so that's 50, plus 10 gives me 60. Remember what I want is 54. I saw one right answer. Right, Amatle is on it. Amatle has told us that the answer or the coat should be 9, which I completely agree with. If we go and have a look here, oh, this is working so well. If this coat is 9, and this coat is 9, 9 times 5 is 40. No, it's not. So I just lied to you apparently. 9 times 5 is 45, and 45 plus 9 gives us 54. And so now we know that the coat is worth 9. But be careful, in the last one, we've got 2 coats. So this is 18. We know that the sunglasses, we've just worked it out, is 10. And so now we need to perform this operation. Now, again, remember it's plus and then a times. So the times has to happen first. So I'll give you guys a second to try and work that out for me. What is the value of this last expression? Very nice. Well done. 187, because 10 times 18 is 180, plus 7, 187. My pen was really doing so well for a long time, and now it's just decided no. Nice, guys. Well done. So basically, this is how we do these maths emoji things. They're basically equations, just without the letters. So Sometimes it'll be something like this. Sometimes our puzzle might be a bit different. And we'll mix it up every now and then where I just let you go and we wait for the first person to give an answer or whatever the case is, but well done. And again, it might look like something silly, but this is equations, so it really helps us. I don't know if anyone wants to take a screenshot, but I'll wait here for like a second or two in case you do. And then we're going to carry on with our equations. Okay. Right, so if we go to 3.3 here, what's now different with this equation is that we've got a fraction. Okay, so we've now got a fraction in this equation that we need to be mindful of. Now your steps don't change. You still want everything with the x on the left, everything that is constant on the right, but the fraction does mean that when we eventually get to working with inverse operations, we need to remember what a fraction means. A fraction means division. And so the opposite of that is then multiplication. But let's have a look and see. So right now, the first thing I want to do is I want to get all the x terms on the left-hand side. Now, as it stands, the only x term that I have is the fraction, and that's already on the left. So I don't actually need to do anything. What I do need to do, though, is I need to get this -3 to the right. And we know that the inverse of that is 2 plus 3. So I'm going to add 3 on both sides in order to get my constants all on the right. So I've got x over 2 is equal to 7 plus 3. Now let's just neaten up the right-hand side because we all know that 7 plus 3 is 10. And now again, my goal is to get this x alone. I've already said that we need to remember that a fraction means division. And so the opposite of division is multiplication, which means that if I times this term by 2, I can get rid of the denominator, leaving me with just x. But I can't just do that to the right-hand side. I also need to do it. No, I can't just do that to the left-hand side. I also need to do it to the right-hand side. Don't know my left and right. It's a problem sometimes. And so what we end up with is that x is equal to 10 times 2, which we know is 20. I'm just going to carry on up here. And again, you can go and double check yourself if you want. If you go and put 20 back into this original fraction, let's just do a little blocky here. We would have 20 over 2 minus 3 should equal 7. 20 divided by 2 is 10. 10 minus 3 we know is 7. And so we do get that 7 is equal to 7. And so my value for x that I've gotten is correct. Right, I'm going to let you take a screenshot. I'm not going to do 3.4 just yet. I want us to practice another one here with the fraction. So I'm going to give us another example before we move on. But I'm just going to give you a chance to screenshot. Okay, I hope we've all got our screenshots. So we're just going to do an extra little one here. Please work for me. Right. Trying to do quick maths in my head. Clearly, my brain is still on holiday mode.
Maybe +1 equals to 4. Oh.
+1 equals 4. My brain's still on holiday mode. Okay, right. So this is our equation that we've got. 3x over 4 plus 1 equals 4. So I want you guys to have a look at this and try for me to solve for x. So look very carefully at what inverse operations you need to use. Look very carefully where the x is. We can see that the x is in this fraction over here. Come on, why do you want to fight with me? The x is in the fraction, so we need to bear that in mind. And so we want to use our inverse operations in order to solve for x. Remember the steps, x is on the left, constants on the right, and then we can go and simplify. If you're feeling brave, you can raise your hand and let us know how you do the answer. Otherwise, you can put your answers in the chat. What I actually will do for you as well is we can do this so you can see how we did 3.3. Just to help you along a little bit. And again, if you want to raise your hand to let us know, please do. Some good answers coming through so far. Again, if anyone wants to raise their hand to explain for us, please do. We'd like to hear your voice. Anyone want to raise a hand? There's some really good answers on the chat, so we definitely are getting it right. Does anyone want to explain it? I know some of you are struggling with network and stuff, so that might be why we're not able to potentially raise our hands. That's cool. I'm gonna take it as no one wants to explain, and so that falls on me, which is cool. So let's have a look. I'm just gonna make this bigger again so that we've got some space here. If we go and essentially follow those steps that we said, oh no, I'm gonna stop talking. Asetu, tell us. You just need to unmute on your side. There we go.
I will say 3x divided by 4 plus 1 is equals to 1x. I think 1x minus 1 is equals to yeah. We say 3x divided by 4 plus 1 is equals to 1. And we say 1 minus 1 nothing, and x will be standing alone, and we'll say x is equals to 4.
Okay, cool. So definitely agree with our x equals 4. And as Asetu said there, because we originally had the plus 1, we need to minus 1 on both sides. So that's where that minus 1 is coming from. Once we've subtracted 1, we have our 3x over 4 is equal to 3. And then because we've got that fraction situation, we've got our inverse operations, which tells us I need to multiply by 4 to get rid of the denominator. But I have to do that on both sides of my equation. And so what I'm left with is 3x is equal to 12, because we know 3 times 4 is 12. And then finally, we obviously don't want 3x, we just want x. So I need to divide both sides by 3. And we know that 12 divided by 3 is 4. And so using all of our inverse operations and the steps of getting certain terms to the left and to the right, we're able to solve our equation. Now, guys, fractions doesn't necessarily mean it's harder. It just means that there is that inverse operation of needing to multiply to get rid of the fraction or to get rid of the denominator when we do our inverse operations. So always remember, when solving equations, inverse operations is very, very important. Thank you, Asetu.